Hey everyone. In this video, we're going to introduce the idea of logical deduction. Logical deduction is the art of using logical rules to determine when a given conclusion follows from a set of premises. This is the primary way in which we're going to really use logic in discrete math, because this is the structure of proof. I assume some premises for my proof, and then I try to show that the thing that I want to be true is in fact true because it follows from those premises. So we are familiar with logical deduction from just how we reason about the world in everyday English. So here's a quick example of a deduction. Proposition one, or premise one, if you will, if I go swimming, so we're starting with an implication, if I go swimming, I will spend a lot of time in the sun. Okay, fine so far. If I spend a lot of time in the sun, I'll absorb vitamin D. That's my second premise. Then premise three, hey, I did in fact go swimming. That happened. Okay, so what follows from these three statements? Well, if we kind of look at how they're set up and just follow out the sequence, I say, oh, well, I went swimming, so that means that this first part, the antecedent of this implication, is true. That means that I must have spent a lot of time in the sun. Okay, so now I know that I spent a lot of time in the sun, and that means I absorbed a lot of vitamin D. And so my conclusion here, something, not necessarily the only thing, but one thing that I know to be true, is that I absorbed vitamin D. So just kind of from our standard way of reasoning about the world, we can say, okay, if these three premises, P1, P2, and P3, if those are all true, then one unavoidable conclusion is that I absorbed vitamin D. Now, note that when we talk about this kind of deduction, we call this deduction valid if it's true that the conclusion follows from the premises. Now, it's important to understand that doesn't mean the conclusion is true. The conclusion might be false because the premises might be false. For example, here's a false premise. Today it is Monday, September 16th. I did not go swimming today. Premise three is false. I did not go swimming today. So it's not that the conclusion is true, it's that the conclusion necessarily follows from the premises. If the premises were true, then the conclusion would be true. Now, if this sounds to you like the kind of thing that we could write with a logical implication, it is. One of the ways to say that this is a valid logical deduction is simply to say, hey, if I look at all the premises, P1, P2, P3, the conjunction of those premises implies the conclusion. So this is another way to say the deduction is valid, is that the conjunction of these premises implies the conclusion. There's usually a different way we write this in order to make it a little more readable and also a little more possible to do new logical deductions, which we'll introduce coming up. Okay, so let's introduce our notation for logical deductions. First, what I want to do is I want to parse these premises, P1, P2, P3, as logical statements. So for the statement, I went swimming, I'm going to mark that with an S. That's going to be the proposition that I went swimming. I spend a lot of time in the sun. I'm going to mark that with T. And then absorb vitamin D, I'm going to mark that with a D. So if I look at the three premises I have here, I can write them out in logical notation now. So premise one is just saying that S implies T. Premise two is saying that T implies D. And premise three is saying that S is true. Then the conclusion is saying that D is true. So I can use this logical notation to describe everything that's going on. And if we take our idea down here, that what I'm really saying is that the combination, or the conjunction P1, P2, P3 implies the conclusion C, well, I could write that in the form of a logical implication. So let's give it a go. We would have S implies T, and T implies D, and S all implies, the little parentheses around there if we want to, the conclusion, which is D. Okay, so if I look at this, honestly, what I feel is intimidated. This feels complicated. There's all these nested implications inside the conjunction operators. It's just a little too much to fit on one line. And so the way that we actually write logical deductions in order to be able to kind of work with them and flexibly create new deductions is going to break these things out onto different lines. So here's how we're going to write logical deductions. We're going to put each premise on its own line, and we're going to label it as well. So I'm going to say, hey, premise 1, S implies T, and I'll just write premise 1 beside it. Okay. Now, premise 2, T implies D, and I'll just give that a label as well. There's a reason we'll use the labels shortly. And then finally, premise 3 is simply S. That's my premise 3. And then what we're going to do is we're going to put a line under all of these. And we're going to put a symbol here. This is the therefore symbol, little 3 dots arranged in a triangle. Therefore. And then we're going to put the conclusion, and the conclusion is D. We don't necessarily always label the conclusion, although we can. So this is the form that we'll use for logical deduction. We're going to have each of our premises on a new line. Then under all the premises, we are going to put a horizontal line followed by a therefore symbol and the conclusion. What we're going to do is we're going to start asking ourselves, hey, this is a deduction. How do we prove it? How do we know that this deduction is valid? How do we know that the conclusions really follow from the premises? When we looked at the intimidating version of it that was in this form with logical operators and conjunctions, in theory, we could have simplified that using rules of logical equivalence. Now we've written it in a way where that's not really going to be a very easy thing to do, but instead there's going to be other operations we can do to check that are going to make this process rewarding. Let's turn to those.